Hello everyone, this is the video lecture for Precalculus Chapter 9.1, Vectors. So this one's kind of interesting because it's technically part of the Chapter 8, I guess, section chapter. So they start with 9.1 on your homework, and then they jump to 8.1, 8.2, 8.3, 8.4, whatever. So this is kind of weird, but it's grouped in with the Chapter 8s, but then all of a sudden it's after Chapter 8. Not that it matters. We're going to be talking about vectors, and this is fun. It's cool. It's new, and you'll see it again eventually. Here we go. How the homework in the book approach it is they use v as a vector. Now notice I'm making it bold. That's how they do it. I am not going to spend the time to do bold every single time. Instead, I'm going to use the letter with like a little arrow thing on top. Okay, that says vector. It's a little arrow on top says vector. An example of this could be something like 2, 3. Notice that this is inside of what I call the alligators, chomp chomp, that kind of thing. So it's inside of vector signs. That's a vector, and this is basically just x and y. There is a difference between a vector and a point. A point p, 2, 3, or just a coordinate points with commas. This is not a vector. It's similar. I'll describe that to you here in a second, but it's not the same. These guys are saying this is now a vector. Another way they often use it is with I and J. I and J. Notice that this has a little hat on top versus the little arrow says this is a whole vector. These are actually called components. This is I component, J component. I guess I could write component. There you go. It might be called component form or something. I don't really know. I don't read English very well, but basically this is components, and they're identical. Again, you got X and you got your Y. Okay, cool. What does that look like? So a vector is what I would say, like geometry-wise, is called a ray. A ray. A ray basically starts and it goes out from a point. The origin is basically where we're starting, and we're going out until the point 2, 3. So there's the difference between a vector and a point. My vector, this is my vector right here, while this is the point. Okay? Now, we can draw them, on top of one another, but the vector is that arrow, is that motion going out towards whatever coordinate you're thinking, while the point is just a dot, a solid, at that coordinate. Okay? You can do all kind of things with vectors. You can add them, subtract them, multiply, some divide, etc. There's a lot of different things to do, and we will not be doing all of them today, but we will be doing some, and that'll be cool. So 0, 0, 8, they start with a graph where I got one vector over here at -4, 2, and I got another vector over here at 8, 3, and they say they want 3u plus v. Let me go ahead and remind you this is a u here, this is a v. That would be helpful to know how to do this problem. And they want to know what that answer is. What is this? Well, I'm going to say 3 times my u and then plus my v. Notice that I converted my points over into vectors. So again, you're thinking, oh, I should have used vectors here. Well, I'm telling you where the coordinate is at the end. Those are the points there. Tick, 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 tick. That's an 8, etc. Okay. I guess I probably should use these arrows here. My notes have them. But regardless, you're getting the idea. If someone's trying to be picky about it, obviously I'm going to be more picky. But generally, parentheses, vector signs, you get the idea. We're going out to this coordinate. Okay. So then I'm going to just do this math. What would you think of how this works? Well, I would distribute 3 first, honestly. And then I would combine like terms, I guess you could say. So x's go together and y's go together. So we got a -4, and then we got a 5. And, well, actually, hold on. Why did I have a 2 there? And it's being recorded. That's not a 2, that's a 6. 3 times 2 is 6. Okay. Well, you know, I mess up on the basic stuff too. Good thing that I can correct myself, though. So there you go. All right, cool. You get that lecture experience here with me. That's just a way to say this is informal, I'm going to mess up. So my answer is -4, 9, which is somewhere out over here, when my original was -4, 2, and this 8, whatever. How this works is I'm going to take 3 of these u's here, and then 1 of these v's, and I should end up right here. So how's that going to look? Again, these are not perfectly to scale, but my idea is that I'm going to take 1, 2, 3 of these guys. That's 3u, and I'm going to go also a v. That's a v. This is a u. This is a u. This is a u. So 3 u's and then 1 v. I'm going in that same direction, there. See how they're parallel? And I should end up at that answer. Okay, that's called the graphical approach. I wouldn't be doing that with math, but it is something that you could do. I guess if you had like graph paper or something. 91018. I got my vector v is equal to pq. Now notice this is interesting. P and q are both points, and I'm going from p to q. From p to q. You see how that works right like that? I'm going from p to q. They give me what p and q are. They're just points. Something kind of like that. And how am I going to find my vector going from P to Q? The formula is very simply, I'm going to show you this formula, it's very important. Terminal minus initial. Terminal minus initial. So Q is the terminal, minus initial is the P. Now this here is bad math. Okay, English is fine, but when you start actually mixing the letters together, it kind of is weird. So I'm just going to use, now in vector form, my Q minus P, essentially. Terminal minus initial. I'm going from this to that, so terminal minus initial. It's kind of like backwards, I guess. This negative sign I would distribute first. I won't be doing every basic thing like that every time, but you get the idea. -1 and the 9 make an 8. -1 and the 6 make a 5. And there's your answer. Notice that like I'm always using these alligator vector symbol thingies, the less than greater than symbols, in order to put my answers into WebAssign. It also accepts the component form on, I'd say, nearly all of those. So if you wanted to go and click I's and J's, I guess you could do that. What I don't always know is if it understands you typing just a plain old I and a plain old J. Now, things improve over time. Sometimes I think I remember that it accepts that sometimes. I'm not 100% sure. Try this out on your homework and see if that works. But, of course, they actually have the actual components on that side toolbar. I mean, in case you want that. Honestly, I just use the less than greater than symbols all the time. That's just me. 91027. Except on this one, very specifically, they say use your I and J. Use component method and all that kind of stuff. And so they just want you to rewrite it using the I's and J's and K's. They kind of knew that I was teaching the class, I suppose. They said, oh, he's going to just keep using those alligator things, those less than greater than symbols, until we tell him to do something otherwise. I mean, I'm just rewriting it using I's and J's. That's all this problem is. Make sure to go, and whenever you have this problem, there's a big old toolbar on the side here, and you like click something and it brings up a big old drop box, and you find your little I's and J's and clicks and puts it in. You get the idea. Do that. Again, you can try just typing I and J from the keyboard. Maybe that'll work. I don't know. Things get better sometimes. Sometimes they improve the technology a little bit. I got U is equal to 1, 9. By the way, I've been using vector V, and all of a sudden I'm starting to use U all of a sudden. Well, it's just like kind of like saying f of x, g of x. It's, h of x. They're all the same. It doesn't really change what's going on. So U and V, they're all the same here. My V vector is 2, 18. And they want a couple things. They want 2U. I'm just going to go and do it. So 2 times my U, distribute to get 218. Oh, I see. I messed this one up. I'm like, why are they the same? I'm sorry, I messed this one up. We haven't even used it yet. Informal. That's what this video is. I messed up twice now already, and it's, what, only been a couple minutes? Yay! Okay, cool. So there. Now they want negative 3v. And it's a good thing I got the correct v now. Distribute. I got negative 12 and a negative 6. They want u plus v. So I'm just going to take these two guys and add them. 1, 9 plus 4, 2, 5, 11. And then finally they want 3u minus 4v. So 3 times my u minus 4 times my v. Oops. Distribute, distribute. 3, 9 times 3 is 27. And then I got my 16, my 8. Putting it all together. I sure hope I get a negative 13, positive 19. Okay. Moving on. They want all this again, basically. Honestly, I think it's a kind of a boring problem. But hey, you know, we get through it together. Informal. So they want, oh, I see, they want something different here. They want the magnitude of u. So I'm going to write magnitude. Notice it says absolute value sign. Kind of an interesting story here with this. Story is not a history story. It's just me talking to you. Let's give like a little demo on what's going on here. Let's say I wanted the absolute value of 2. You would say it's 2. What's the absolute value of negative 2? Is positive 2. What's the absolute value of negative 2 comma 3? You're like, well, I don't know. Well, what's going on here is I'm going to find find it with Pythagorean Theorem. So negative 2 squared plus 3 squared. I'm going to show you why I did all this stuff up above. It's not absolute value anymore. It's magnitude. So it is going to be different. I get, what, a 9 out of that guy. So that would be, what, a square root 13. Cool. But notice it's a positive. Notice it's a positive. Even if I had 2 negatives there, it would still be the same thing, okay? You're always going to get a positive here out of this magnitude stuff. Magnitude is always positive. Magnitude is always positive. Isn't that interesting? You're basically, like, let's do this formula here. Like, what, in a way, is there a variation of this kind of formula? And you think, well, it's just simply, you just take out the minus sign. But, like, think like a computer for a minute. How does the computer know to do that? It kind of has to have a formula. And so I'm gonna make up a formula for this, if that's okay. I'm going to say the square root of whatever I got squared. The square root of whatever I got squared. Well, 4, all right, 2 squared is 4. Square root of 4 is 2. Here I got 2 negatives make a positive 4. Square root of 4 is 2. Do you see what I'm doing here is I made a formula for the absolute value sign just now. What it looks like, kinda, is this Pythagorean theorem. Basically, I was saying this, and I just leave it. But the Pythagorean theorem would keep going. And heck, you can even keep going to the, I don't know, the next number. So that's 3 dimensions. So absolute value is just the one-dimensional magnitude. Okay? One-dimensional magnitude. That's why we use the vertical lines. Magnitude, kind of like saying absolute value. But if you were to say that, that would be an incorrect statement. Like, you know, between you and me, you say, I want to take the absolute value of a vector. I kind of get what you're saying, but that's not really what we say. We say magnitude. Often to differentiate this, some books use the double lines to say magnitude. And that way we know for sure we're talking like a real Pythagorean theorem, not just me trying to make it up or backwards, whatever. There you go. Either way, there's my little story. Math trivia. So let's actually do it. The magnitude of this u is going to be then 5 squared plus 1 squared. I got 25 plus 1 is going to be the 26. And like that's it. Magnitude of v, square root of the 2 squared plus the 4 squared. Whoa, whoa, whoa. That was a negative 4. What am I doing? I did not mess up this time. I didn't. I just wanted to show that even if you have a negative or a positive, it doesn't matter because they're all going to square out anyways. Do you see how I'm still thinking kind of like absolute value sign in a way, aren't I? I don't care about that it's negative. I'm going to put in a positive regardless, and it still works the same. Interesting little fact there, I guess you can say. 4 plus the 16 is 20. And you don't have to reduce these. Remember, you don't have to simplify in WebAssign. Magnitude of 2u. And so I'm saying it's the magnitude of 2 times that 5, 1, which would look like 10, 10, 2. And then I'm going to find that with Pythagorean Theorem. Could I simply, I don't know, put a 2 in the front here and just call it a day? Oh, let's see, maybe. I got a 100, and then I got a 4, so 104. Could I say that this is just 2 times the square root of 26? And so if I were to do that, I would want, I'm going to use a calculator. I just want to see if that works. Very informal today, it seems. Yeah, it sure does. Look at that. So I could rewrite this as 4 times 26, 2 square root of 26. Basically, I just put the 2 in the front. 2 in the front of what I originally had right there. That was nifty. I didn't even know that myself. Glad we talked about it, though. That was fun. What's my answer? There, they're all the same. Whatever. Magnitude of u plus v. Notice that I definitely have to add first. And then I can go and find the rest. Make sure to have that negative this time, okay? We haven't gotten to absolute value sign yet. So 5 plus the 2 is a 7. 1 minus the 4 is a negative 3. And this guy, I'm going to do that Pythagorean Theorem. 7 squared plus the 3 squared. Math. I'm actually going to double check myself in the calculator. I got 58. Sure enough. Square root of 58. Last one. It says magnitude of u minus magnitude of v. Notice that these guys are separated. They're saying, okay, find the magnitude of u. I got that. Find the magnitude of v. Okay, well, I got that. Put a minus sign between them. Okay, I could do that. Ta-da, we're done. Pretty easy. 91044. I got the magnitude of v is equal to 650. I got theta is equal to 125 degrees. And they want to know what the vector is. What is v equal to? You know, what's funny is this is one of the most missed questions on quizzes and exams that I've seen from this vector stuff. Like, there's some vector questions, let's say, on your exam. Most people get it right because it's just a graphing or one of these other guys. But this one, so often people get wrong. So I want to show you the formulas. It's not hard. It's just, you know, you got to do a little bit of math. V in point form, I guess you can say, is like x comma y, right? That's basically my point or coordinate or whatever you want to call it. Well, I can rewrite these in terms of a magnitude, or I guess you can even call this a radius. They're all the same, radius. That's kind of interesting. And then we got our angle, right? I'm starting to think radius, angle. I'm starting to think trig, like sine, cosine, and tangent, that kind of thing. Well, let me remind you that sine theta is equal to y over r, right? Well, to solve for y, I'm going to move the r over, so y is equal to r sine theta. Same thing with the x is r cosine theta. These are super important formulas here. Now, I've swapped them, unfortunately. Sorry, so x and then y. And so I want to find my x and y vector. So I'm going to say my r cosine theta, so 650, cosine of the 125, and then my sine is the 650, sine of the 125. Make sure you're in degree mode. Obviously, you're working with degrees here. And I got decimals, and that's okay. Negative 372.8246. And then I've got 532.4 .4488. There's your answer. They are okay with decimals on this one. Okay, let's do some more. 91047. So we're basically using trig with vectors now because we can. I got 3 comma 4. They want to know what's the magnitude of v and then what's my angle theta for this. So if I were to graph this 1 2 3 1 2 3 4 there, they're wanting to know what's this angle here and then how much distance is this right here, r. What's that distance? My radius. Well, my r radius is going to be the magnitude, which is also going to be Pythagorean Theorem here. 3 squared plus 4 squared. When you do the math, it just ends up 5. Square root of 25 is 5. That's one of your answers. We need to have another formula for this guy, of course. I'm going to give this to you as the arctangent of y over x. Now, there's a few ways you can solve for theta, but I'm going to recommend this formula here because it's super helpful. Actually, I don't want to write it just like that. Let me finish up this problem, and then I'll give you all the formula stuff, okay? So, arctangent of y over x. So then I got arctangent of 4 over 3. Definitely calculator, and remember degree mode, 53 degrees. Let me give you the formulas. Kind of like a summary of all this stuff. X is equal to r cosine theta. Y is equal to r sine theta. So these are super important. My r is equal to the square root of x squared plus y squared. And tangent theta is equal to y over x. Now, I don't have a problem here, at least that I'm doing in this section, that will utilize the whole theta, tangent theta thing more, I guess. But we will be seeing it eventually. It might be calculus, I can't remember, but you will be seeing it eventually. Notice that I'm leaving it as tangent theta equals this stuff instead of saying theta equals this guy. Like, this formula is true, but there's a little bit that it's kind of lacking, I guess you can say. Here's the idea. What if I had a point -2, -3? So then I got -2, -3 is down over here. Well, when I do theta equals arctan, notice that I'm going to have the negatives cancel. And let me just do this real quick in my calculator so that we're all on the same page here. Yes, degree mode. So arctan of 3 over 2, again, the negative signs cancel. I got a positive 56.309 degrees. And you're wondering, well, 56 degrees is over here. That's 56 degrees. All right, cool, awesome. That has nothing to do with this angle over here. So what's going on? Well, I have to add 180 to get the correct angle here, because I know that this guy is down here in quadrant 3, so plus 180, and now I've got the 236 degrees, which makes more sense for this quadrant 3. I know it's quadrant 3 because, again, x and y are both negative. So arctan alone will not give you the answer every time, and so you might have to add 180. Maybe you don't. Maybe you have to add something else. I don't know. So what I'm saying is just be careful. This right here doesn't say left or right about adding the 180. It just is a general formula. Okay? So that's my little story yet again. I got a lot of stories today. V is equal to 6 comma 2 square root of 3. Again, notice that they're both positive, so we're seeing something here in quadrant 1. Everything should be fine here. Magnitude of V is going to be the square root of 6 squared plus 2 square root of 3 all squared. Math. 36 plus 12. Again, that's going to be 4 times 3 is 12. Square root of 48. And I know that'll reduce, but here I box it in. My angle theta is simply going to be the arctan of y over x. And it should be straight up. I got 30 degrees straight up. Now, again, I just want to remind you that this is in quadrant 1. I already know that I should be getting a 30 degrees. That makes sense. Like, this is good, it makes sense. If I were down here, or even over there, 30 degrees does not make sense anymore. So I have to kind of readjust what I would get from the calculator to actually fit the true answer, okay? That's why I graph it. That's why I make sure that everything makes sense when I do this. 91053. This is a word problem. So I have someone here pushing a lawnmower, and this is like the best, picture ever. So they're pushing a lawnmower. Notice that they're pushing down on the lawnmower. Okay, like if you were to graph that angle, it's actually right here 30 degrees, and they say that they're pushing with 30 pounds of force. I don't know if that's a lot or a little bit, but they're pushing with 30 pounds of force at 30 degrees. I want to redraw this because this is nice and all, but I really like vectors, and vectors start here at the origin. Notice the direction of the arrow is very important, so it's actually going down this way. So I'm going to say negative 30 is actually my true angle for what's going on here. And they said it was 30 pounds, which is kind of my magnitude. I guess you could say like r is equal to that. They want to know what x and y are. What's the vector? So xy would then be 30 pounds times cosine of negative 30 degrees, and then 30 pounds times sine of negative 30 degrees. Notice the sine and the cosine. We can do an exact answer here. I don't know if they really want it or not, but I have that for my answer. Square root of 3 over 2 for my cosine, and a 1/2. Actually, it's a negative 1/2 for my y value. This is what I have. I would type that in, and it should be fine. Okay. I think it's unfortunate that it's 30 and 30 degrees, 30 pounds. That's kind of weird. So if you wanted to go back and just kind of redo this to say like 40 pounds, that way it's a little bit more like, oh, those numbers now make sense. Okay, that's what I would do. Okay. Cool. Next question is about airplanes. I got 91061. So there's this airplane. I'm going to draw the best airplane I can. This is not the best airplane I can, but it's going to work. There you go. There's an airplane. He's got a little propeller going that way. He's traveling this way, and if you measure it, that's 30 degrees from due north. Okay, so 30 degrees from due north, and he's traveling at 750 miles per hour. That's a lot. But then there's also this wind pushing him this way. The wind is at 30 degrees from north, but in the other way, the other, direction, and the wind is 55 miles per hour. So we got plane, and we got wind. And what they're saying is, the plane is in the wind. What is where's the final direction of the plane? Obviously, the plane's still going somewhere. So what I have is like this magnitude here at, the plane. I'm going to try really hard here. It's like really big. This is 750. While the wind is only 55, probably about like this. Okay. So, what's my result? If I add these together, I'm just literally, I'm either taking this one right here and going this way, or I'm taking this bigger one and going this way, but you can see what's going on. I end up over here. My final direction is going to be this way here. That's my final. Here, let me try it in a different color. That's my final vector answer, is this direction here. Now, it's not straight up. It's definitely still quadrant 2, but it's not 30 degrees anymore. It's less than 30 degrees from the north, okay? So now you know what the problem is. Let's understand also to get the correct angles. Notice if I'm going 30 degrees this way from north, where's that true angle going to be? Well, that's 90 plus 30 is 120. If I'm going 30 from north right here, right, for the wind, so this is my plane. I'm going to say plane. My wind is going to be what angle here? 60. 60 plus 30 would make that 90. So my wind is a 60. Okay, so I got my true angles. What I'm going to say is plane plus wind equals answer. Okay, that's what I'm trying to go for. Plane plus wind equals answer. So I've got the 750 cosine of the 120, 750 sine of the 120, that's my plane, plus, and then the next guy I've got 55 cosine of the 60, 55 sine of the 60, and then equals my answer. I'm just going to tell you, I'm going to combine like terms, my x's, my y's, in the calculator, and I got negative 347.5, 697.15045. Again, this is an x and a y. We still are in quadrant 2 because you got a negative x and positive y. That's good. All right, are we done here? No, because they want the magnitude and then the angle. The magnitude of that right here, of this new vector, is going to be the Pythagorean Theorem. Negative 347.5 squared, 697.15. 5 didn't look very good. 0.45 all squared. When I put that all into the calculator, I got 778.9576. And that's miles per hour. Okay, so I got my magnitude. What about my angle? How do I do that? Well, remember that my angle, theta, is going to be arctangent of y over x, yeah? Well, let me go and put that in. So arctangent of my y over my x. I probably kept a couple more decimals whenever I did the math here. And I got an angle of negative 63.5056 degrees. Now hold on a second. Negative 56 is like down here. Is that where my plane's going to end up? No, my plane's going to end up over this way, right? So how do I get to this angle right over here? I'm going to add 180 to it. So I'm going to add 180. And that's how I got... well, I'm going to tell you my answer, 116.4943 degrees. I put this in, it said, you're wrong. And I was all upset and all that. What do I do now? Well, this is good. This is my quadrant 2 answer, but they're wanting it as bearing. My degrees bearing. Basically, north is 0, and I think it goes clockwise. I can't remember. Anyways, maybe it's not clockwise. Maybe it's counterclockwise. Regardless, they're starting at north here, and I'm going to give the answer. It's actually pretty easy. Oh, I know. It doesn't matter because they probably put something like north, and then this is west, so west. North, some amount of degrees west. So what is this angle right here? How do I get that? Well, again, I'm just looking here. This angle is 116, right? But I only want this tiny little angle, so I'm going to remove that 90. So 116.4943 minus 90 degrees should give me that small little acute angle, 26.4943 degrees, and that is finally my answer. Whew. We're not done. One last problem. And this is a big, big one. 91074. If I didn't do this one, I know you'd ask about it. Probably get questions regardless on this one because it's big. There's this crate being suspended with these wires. And I got T1 and I got T2. T stands for tension. Over here I've got the 22.3 degrees. And on this side I got the 41.5 degrees. And this thing weighs 18258 pounds. Awesome. What they're wanting is to know, I guess you can say like the tensions on these guys. What's the tensions? How much tension is on each of these lines here? So I want to make sure that I do something correct before I keep going. Don't use this 23 at all. Instead, you want to use this angle here when I start doing math calculations. That's going to be the 180 minus the 22.3, which yields my 157.7. That's the one we should be using. And this guy's fine, of course. So T1 is associated with the 157, and T2 is associated with the 41. So I need to set up a system of equations. This is how it works. I'm going to look at my x's and my y's separately. my x's should actually end up equaling 0. The reason why is because this crate is not moving side to side. He's stuck right there in the middle, okay? So he's not moving anywhere. He's not x, my net x should be 0, okay? This side is pulling just as much as that side x-wise. And so then I would say my T1 magnitude times the cosines for x's, of the 157.7, and then plus, is it plus? Yeah, plus T2 cosine of the 41.5 degrees, and that should be equal 0. You're wondering why there's not a minus sign, like this guy minus that guy or something like that. Well, this right here is going to end up being a negative number anyway, so this is a negative, that's a positive. Negative and positive should equal 0. That's the idea. Now, T1 does not equal T2. There's a little bit of different magnitude, okay? My y's are different. Notice that he's not actually going down. I'm just saying he's like suspended, but he weighs a lot. So my tension for the y's, again, they're pulling up. They're pulling up. Whenever I add my two tensions, what is it going to equal? Not 0 anymore. It should equal the 18,258 because my pull up is the same as the pull down due to gravity. Therefore, the box is suspended in midair. Okay. Notice I have a system of equations and I need to solve for T1 and T2. That's going to be the goal here. What's T1? What's T2? Once I get them, we're good to go. The best way to do this, honestly, is to move one over, start solving, all that kind of stuff. And so what I did is I moved this to the other side, and then I divided this over here. So I got T1 is equal to a negative T2 cosine of the 41.5 all divided by the cosine of the 157.7. Okay. This is just some kind of, a number. This is just a number. I don't know what that number is. It's just a number. I'm going to leave it alone for right now. So I use the top one. Now let me use the y's. I'm basically going to replace right here this T1 with all of this. And then I'm just going to rewrite the whole thing, okay? So I've got negative T2 cosine of the 41.5 divided by cosine of the 157.7 times the sine of 157.7 plus T2 sine of the 41.5 is equal to the 18,258. Whew. Now notice that I have a T2 and I have a T2, and those are the only unknowns. So technically I should be able to solve. And that is true. What I'm going to do here is take these right here as a single number, and I have this as a number. And so what is that supposed to equal? I think I even put the negative sign in there too as well, didn't I? Yeah, that negative sign right here. Hold on. I put that inside as well. Because, like, this is a negative, that's a positive, and that's a positive, so two negatives are going to make a positive in the end anyways. So I end up with a positive 0.307169 T2 plus 0.66262 T2 is equal to the 18,258. Obviously, combine like terms, and then I'm going to divide it to the other side. So that's a 0.969789 T2. Divide. And so I've got T2 is equal to 18,826.78. I think it's pounds. Yeah, pounds. Tension pounds. There we go. And then T1, actually we have a formula for that, right? If you go back, oh, I'm sorry, it was the 40 in the top here, 41.5, 157.7. So I can plug that in. This is just a big number. Put it all in, and I get a T1 is equal to 15,240.25. Okay. So that's my T2, that's my T1, and we're done here, right? Well, no, actually we're not, and that's the sad part. we have to keep going. They want the actual vector for T1, like the vector. Now, they don't really say that so directly. They just do this. And if you put a single number in there, I'm pretty sure they'll say either incorrect or they'll say, I don't understand your answer. So don't just put the 18,000 whatever. We're going to have to go and figure that out ourselves. And it's not too hard. Remember that we're just using the sine and the cosine here for x and y. So vector sine, T1 is using the 15,240.25. Cosine of the angle associated with T1 is the 157.7. 15240.25. Sine of the 157.7. And I put all that in decimal-wise. I got 14100.658. 5783.101. There's your answer. And then T2, same thing. This time instead I'm going to be using the 18826.78 cosine of the 41.5. That's what it was. That's the angle associated with the T2. And copy paste over here again. Sine of the 41.5 degrees. My answer here in decimal form, 140. Yeah. Okay, yeah. You're going to see something really weird here in a second. 0.424. I'm just writing out what works, and I'm going to show you that it's a little funny, actually. 0.001. Here we go. Okay. Notice that my x values are basically the same, right? Isn't that kind of funny how that works? My y values, I think, would they add up to be that answer? 5783 plus 12475 is the 18. What do they have? What was my original? 18 something or other? 20. Yep, that works. So my x values here, let me use a different color. These x values here, they add up to be a 0, and these y values here add up to be that 18,258 or whatever we had. It's kind of funny how that works. Okay, we're done. That was it. That's all I got. Thank you very much. Have a great day.